Hi everybody. Today we're going to continue our deep dive analysis of the Hermes ransomware. In the previous video, part 1, we worked on unpacking the payload and got down to the ransomware itself. We're going to pick up where we left off and we're going to do the deep dive analysis process on the unpacked payload. So deep dive process is really a lot of pattern recognition. So the more you understand about what you should expect to see, the easier it is to recognize it in code. So because of that, we're going to start this video off with a very brief introduction to the general steps that ransomware performs. That way, when we look in the code, we know what we should be expecting to see, and makes it easier to recognize it. So to start with, let's go into the general ransomware process. Now, these are the general steps that ransomware provides. Sometimes it'll do more, sometimes it'll be less, and the order may change, but this is generally what you want to be looking for. So most often, you'll create some type of mutex to make sure you don't get infected more than once. You'll decrypt and parse the configuration data. That's going to tell you things like what to encrypt, what to ignore, potentially crypto keys, things of that nature, seed values. You're going to want to check your running level and try to elevate to admin if needed. This is usually through an exploit or just a simple run as with shell execute. This is because you really want to run ransomware as an admin. You don't want to use it as a general user because you won't be able to encrypt all the files. You don't want to run it as a system because you don't want to risk encrypting system files that will corrupt the system. You want to run as admin so you get the broadest range without a risk breaking the system. After that, there is oftentimes some type of check on the region, basically against an avoid list, and then exit if needed. A lot of ransomware will ignore certain regions, usually Eastern European, things like Russia, to make sure they don't encrypt drives in those regions. After that, you're going to terminate targeted process, and this just free file blocks to make sure you can encrypt all the data. And then you'll go ahead and encrypt the files. You're going to do this usually on all local drives as well as all remote drives. After that, you'll drop a ransom note. This may be during the encryption process you put on every drive, on the desktop, and so forth. And then you'll usually get near the end by deleting the shadow volumes, basically the backup copies, using VSS and sometimes other backups like BCD edit. And then finally, if there's any networking, you'll perform that networking to either exfil data or do the communication with C2 server. And that's really about it. So you can see ransomware is pretty simple. There's not that many steps, and they're relatively easy to recognize. So once you know what they are, when you're skimming through the malware, it makes it a lot easier to recognize unknown functions if you can compare to this list of expected capabilities. So now that we know the general steps, what do you want to look for? What IOCs are there to discover? So what you generally want to know if you want to know what regions being ignored, if any. You want to know what folders and files are being targeted, what's being ignored, so you know what's at risk and what to protect. You want to determine the crypto algorithm and the cryptographic key. And then you want to know how the crypto key is conveyed to the actors. And the crypto algorithm key and the convey methodology is mostly so you can figure out if there's any vulnerabilities that will help you write a decryptor, or if it's done in a relatively safe manner that there is no way to undo the decryption without going to backups or paying a ransom. And then finally, you're going to be looking for YARA rules to help block the file before it gets downloaded. And that's really all there is to it for the general process and the IOCs. So with that, let's go ahead and open up the file. And we're going to just pick off where we left off from the last video. So this is the file that's unpacked. The hash of this file is in the video description. You can download from malshare.com to follow along yourself. I'm also going to upload into my GitHub page, which will be linked in in the video description, the fully annotated Ghidra file. But I'm going to wait until we're done this full deep diver analysis process. So when this video comes out, the Ghidra file won't be in my GitHub page. But once we get done this process and finish the deep dive process, I'll have the fully annotated file for this payload. So that way you can download it and review it on your own. You can compare what you got to what we got in this video. It'll just help you for kind of a learning perspective. So because we're doing the static analysis, I'm going to run my general scripts. I'm going to go up to the script manager. And I'm going to go to my scripts. I'm going to highlight the target instructions. And then I'm going to minimize automatic function comments so I get more code real estate on the screen. And then finally, I'm going to get a preview of the function capabilities so I know what I'm looking at before I kind of get into there. So the first thing I often do is I just skim through the functions after I ran that preview function capabilities. And I'm looking here to see what type of capabilities there are. So I can see these have function calls because there's no ZC like here for the 0 calls. But I'm not seeing any labeled preview capabilities. So that means that probably the APIs are resolved at runtime dynamically. And just because I forgot to mention it, if you're not familiar with these scripts, I run these through all my static analysis, and these scripts are also listed on my GitHub page, and you can download them and play with them on your own. All right, so I'm going to open up this graph view, because I'd like to do stuff in the graph view, and I'm going to type G to go, and go to the entry point. So for the deep dive process, I'll just give you a very quick overview. I basically go through a multi-pass process. This first pass, I'm going to be looking for general table of contents overview. That'll give me the context of what I'm looking at, where I'm going from. And then I'll make a couple more passes and I'll refine the names. That'll give me an idea of where I want to look for if I just want to grab the indicators. And oftentimes by spending that first 30 minutes or an hour up front and get that table of contents overview, it will help me determine where I want to look to find IOCs if I don't want to do a full in-depth analysis. And if I want to do a complete markup and analyze every function, it'll give me that context that will save me a lot of time analyzing. So it really does save you time by doing a little bit of upfront work rather than just looking straight for the indicators. The other thing I like to do is I like to go basically read it in the code in the order the actor wrote it in. That gives me all the context of knowing where they came from, where they're going to, and helps me make educated guesses. The more educated guesses I can chain together, the higher my confidence is, and the less I need to read the assembly directly, and the more I can just look for programming algorithms to compare to. So let's just scroll down here. Because I'm looking at this table of contents overview, I'm really looking for strings and API calls. That'll give me an idea of what capabilities are performed based on API calls, and the strings will give me some context. At the static level, I'm just looking at what's capabilities been performed. I'm not worried about the details. The details I'll probably get through dynamic analysis. So I can see I'm going to get a call to get this free space, and then I have this can't get value, and this call which gets truncated in Ghidra, so I'll expand this out. And I see a message box. So this is probably either some type of decoy code, or I see it's install Windows Update, or maybe it's just code to make it look like kind of Trojan code, so it obfuscates what's going on when the user tries to run it. They get the message box. Now I get a call to this unknown function, so I'll double click this and I'll step into it. So again, we'll just go function by function. So this first function, all I'm seeing is a couple math things. Not really sure what it is, but it doesn't have API calls. It doesn't have any strings or constants. So I'm just going to go ahead, hit L to label, and call this unknown question mark, just so that I know I've looked at it before. Alt left to get back. And now I'll just go to the next function. So this function, if we look at, we're grabbing our parameter, comparing it to null. And then if it's not null, we're going to go through and we're going to loop through until we find a null. And we can see EX is our loop counter and we return EX. So it's just a string length. So L to label and call this string length. And then Alt left to get back to where I was at. So we get string length. Looks like a decryption loop here. We have an XOR decryption. That's why I color it with that purpley color. So we decrypt the string, get some more string length. Some more decryption here. And now we have this high cross-reference called 38 cross-references. And I see from the arguments, I have what looks like a buffer, a null, and then a size. So I'm going to guess this is memset based on a high number of cross-reference mix of utilities. The arguments looks like memset. So let's step into this. And I see it is memset. So if you're not familiar with STOSD, this is basically a rep STOSD. This is a inline optimized memset functionality or instruction. So I'm going to hit L to label, call this memset. Alt left. And if I haven't mentioned before, I label all my functions with F double underscore so that I can sort them alphabetically and find what I manually named. So I don't have to remember the names exactly. So I see this kind of ASCII looking constant there. It's unknown function again. Again, just looking for capabilities. I see these constants that look like they're in the ASCII range, more ASCII range. So my guess is I'm doing some type of decoding part. Now I'm kind of looking down at this whole summary view here, getting an idea of what the whole function looks like because it has this decryption type decoding loop. And then I see this long straight line. This tells me that this is a function that's probably doing the kind of loading imports. So I'm probably doing some type of decoding up front here. And then when I get down this long list, this is probably going to resolve my APIs. I know I likely resolved APIs at runtime because I did that preview functions. I didn't get any normally identified functionality. And then one of these first functions had a long list of inside the just long code block. And that's usually indicative of keep on calling get proc address and resolving APIs. I see for this first function has 75 cross-references. So it's a high utility one. So let's look at this. Now, if you aren't familiar with the get proc address manually, I have a previous video that talks about how to resolve APIs by hash. And if you watch that, you'll recognize that if you see the 3 Charlie and the 78, we're looking for basically the export data directory, and that's going to be doing the manually resolving APIs. I'm just going to scroll through here. I see this plus 18, plus 24, 1 Charlie, and 20. So these are all, again, the constants I talked about in the previous video. I'm not going to go over this here because the 3 Charlie plus 78 is really enough. And then I see this loop and I function here. So I'm just going to check here to see if it's doing it by hash. So if this is a hashing function or just a string compare function. So I look at this satellite view and just scroll through here. And I can see this is basically a standard implementation of string compare from Visual Studio's compiler. So I'm going to hit L to label and call this string compare. And then Alt left. And Alt left to get back. So I'm going to go ahead and label this, L for label, call this get proc address manual. So we resolve some type of address, and then we call a global variable multiple times. We see one has a DLL here, so let's see what these other DLLs or global variables look like. So I gotta go back to flat view, and then double click it, and it looks like it's probably an encrypted one. So can't tell what it is, and that's probably what the previous code was doing, decrypting the strings. But given this one is a library, and we're calling the same functions, that makes me think this is probably load library. And then we see we have get proc address manual many times in a row. The result, EAX, is going into global variables, and we see it's different each time. So that means we're basically building a dynamic import address table inside the global variables. So I have a script that's going to resolve this, or really a tool and a script. They're again on my GitHub page, and the tools have a reference to the YouTube videos where I talk about how to use them if you're not familiar with them. So first thing we need to do is resolve these APIs, because you can't really do a deep dive analysis without knowing what the APIs are. And the easiest way, because this is a single function, is to do this in a debugger. So I'm going to Alt left to get back to where I was. I'm going to go ahead and label this function, L for label, and call this load imports. So let's go ahead and open this up in X32 debugger. All right, I'm just going to F9 to get into address space and then see where we want to get to. I want to go to address 404.397, the control G, 404.397. That's our call. I'll F4 to run to it. And then you see these calls like right here are not resolved. I'll F8 to step over it. Sorry, this call up here. And we see they got resolved. So now I know everything's resolved in memory. So now I need to open up my tool to resolve, or basically dump out the labeled IAT. I'm going to open up a command prompt. I'm going to run it as administrator. I'm going to change the demo folder. And then I'm going to run this tool. It's called dump labeled IAT memory. Again, this is my GitHub page that's listed in the video description. And we see we need the target PID, the module base name, and then the output file name. So let's open up Process Hacker. All right. And we can see our PID down here is 6664. So I'll do 6664. The module name is, we can see again from Process Hacker, 773 Charlie 5554.exe. And the output name I'm going to call labeled it.txt. And now if we go back to our folder, we see this labeled IAT. And we see this has the RVAs of every API resolved in memory. And so now we're going to use a Ghidra script. We're going to go back to Ghidra and open up our script manager. And then I'm going to do this labeled dynamically resolved IAT entries, and I'm going to run that script. And all I have to do for this script is select that dumped IET. These basically script and that tool are meant to work together. And then hit open. And that's all I need to do. And now they should all be labeled up. So you can see here now we have this get Windows directory, which previously was unlabeled as just a global variable. So now we have everything we need to start going through it and continuing the deep dive process. So to save a little bit of time, there's a lot of utility functions in this file. Things like memset, memcopy, string length, I2A, things of this nature. The focus of the video isn't how to identify every function because it just takes a little bit more time. It's really about how to analyze ransomware and deep dive process. So because of that, I've already went through and I've labeled all the utility functions. So I'm going to hit G to go and go to the entry and open up my graph view. So this is basically my initially marked up file where all the utility functions are labeled. And we stop at the point where I basically I go up to load imports and then labeled all the things like here, like string cat, all those basic utility functions. So we can focus on what's important for the ransomware. So let's just start going through. Again, we're going to read it in the order the actor wrote it. And so we can get an idea what's going on. So first, I see now, because I ran my scripts that I ran previously, and now I see that I have a registry handle open and a read registry of one-time cross-reference. So if you want to think about this, we're at the top of our payload of our ransomware. So what would we be reading the registry for? There's only two real reasons. You'd either want to be reading a configuration item that got stored there, or you would want to be looking for some type of probably installed languages, basically for the void list. So we didn't go through the unpacking process to really know if the dropper or the unpacker set the registry. So let's kind of step into here and see what it looks like. So I open a key, I see this current control set control, and I see this query value for installed languages. So now because I'm already expecting one of the two options is basically looking at languages to look for in a void list, I know that I'm going to be checking the installed languages and not opening a configuration. I do a string, and if they match, I exit process. String, exit process. So these are basically our avoid list to make sure we don't encrypt files or host computers inside certain regions. If we want to see what those regions are, I pick a global variable, go back to the flat view, and I'll double click it. And then I'm going to right click data, and I'll change it to a C string. I'll do that for these other two also. Right click data, C string, right click data, C string, and then alt left to get back. So we'll check these later on, and later on deep dive process when we're gathering indicators, IOCs, about what these language regions are. We can see if it's the language pack is 0419, 0422, or 0423, then we're not going to encrypt the computer. So alt left to get back. And let's go ahead and label this L for label, and I'll put exit if target language found. And you can see why knowing the ransomware steps helps us understand what's going on there. All right, let's go into the next function. So where you see get version EX, and then we're comparing some local variable to a 5. If you're not familiar with this, we're going to go up to this argument for get version EX. I'm going to go up to the stack and right click it and do set data type and choose data type. And then we're going to search, this should be, we're going to do OS version info. And this one's going to be the, we'll do the wide character structure. And we'll basically apply that structure. And now we can see we're comparing the major version to 5. If you're not familiar with the major version of the OS structure, it basically tells you which operating system you're looking at. So 5 is generally for XP. 6ing up is for Vista and Windows 6ing further. So hit L to label. We're going to call this is OS XP. You can see if it is, we're going to set our return value as a 1. Otherwise, it'll be to 0. So it's basically Boolean check. So alt left to get back. And then we can see result of EX goes in its global variable. So I'll hit L to label and put G for global variable. Call this is OS XP. So if we run across it later on, we know what it is. Now I see I'm basically getting a command prompt. So I'm going to concatenate that onto a variable. I'm going to get my Windows directory. And then it looks like based on my OS, I'm either getting a path, basically document settings or C users. I build more strings, And then I'm going to write out a file. So I open a handle, write out a file, and then create a process. Let's double click it. And I see this was called twice, 2 cross references. So I get my module file name, get Windows directory. I see documents and settings here. Users public. So I'm basically picking what path to build. String cat. Again, get username. More stuff for picking the path here. So app data local. So again, I'm just trying to get an idea what's going on. So I'm really just building strings up here. I see service host. So doing something with files, probably. Command exe. Get my string length, build the strings, and then create a file. So I want to know what I'm doing with the file, if I'm opening existing or creating a new one. So I always go to the 5th argument. So 1, 2, 3, 4, 5. I right click and do set equate. And then the 2 is going to be create underscore always. And 3 will be open existing. You can look those up in MSDN, but I'll change this here so it's easier to recognize. So I'm creating a brand new file. And then it looks like I'm building a string probably to write out to the file we just created. So I see basically a timeout and then a delete. So I'm probably doing some type of basically sleep and then delete a file. And then I see a /f probably for a force. So it's probably a command prompt like a batch script. And then delete a %0. It's pretty common to delete the batch script that you just ran from. Parsing a string here. It looks like I'm parsing for a file name. Because it's 5 Charlie, if I right click and convert, that is a backslash. So again, build out the strings. I see this delete stuff. So building out the strings, so I write out file, probably all that stuff that I just built to do the deletion. So I'm deleting something because as you can see, if we scroll up to the top here, we have this delete here. And then we also have the delete %0. So deleting something and then probably deleting this batch script. And then we have shell execute. So a little bit hard to see this in Ghidra, but you can see this exit path. We can goes way down to the bottom here. Let's see, let's scroll down here. And you see it exits out. So we'll go back. So this is basically a big if-else statement. It's just, again, not the most clear in the graph view. So we had the one path where it looks like we're deleting files. And then we come over this other path. I see something with a .exe, building strings with string cat, application, temp strings, public. So I'm basically picking some type of path where I'm going to build my strings to. Now I see a /c copy /b. That's command prompt string. So I'm going to be copying a file, building strings, and then I execute. And then I see a /c start. So I copy a file and execute it. So again, that's done in the command prompt. The only other file name I saw in here was a service host. So if I had to guess, we're doing some type of copy and then start it. Maybe we're copying into that service host. And probably our paths are going to be something either temp, one of these applications, or public, depending on some type of variable. Those exact paths are the details I'm not worried about. Again, I'm trying to look for the capabilities, what's going on. When I need these details, I'll just run a debugger and pick that out in the debugger or look at it through triage analysis. So I'm going to hit Alt left to get back. We basically looked at this, what we need to. So we can see we hit auto label. We can call this delete file or copy and start file stuff. So the stuff ending I generally put on when I had the category that's in the ballpark, but I need to refine it a little bit more. So that means I know this is not fully analyzed, but that the stuff I have is accurate enough. If I have it, maybe a question mark, it means it's analyzed, but I'm not sure about the results. So the stuff just means I'm sure about what I've seen, what I've labeled, but I'm not complete yet. So if we delete file or copy and start stuff, and then we're going to, looks like drop a file out. So we have a file, open handle and write. We're going to get file attributes. If it's, let's see, compare this to -1. If it's not equal, so we're basically going to come drop here, drop this file. So this is just the inner function. So I scroll through here. So I see this user unique string. And now I see I'm getting cryptocurrency context. So I'm doing some type of crypto, basically opening up my context. So I see this enhanced RSA AES. So basically just open context stuff. I'm going to generate a key, export a key. We have public and then create file. So presumably this might be something like creating like exporting a public key, write out file, export another key, import a key, export key. So I'm just looking at general capabilities. I see this unique ID, do not remove. Create another file, write a file, so we're dropping the files. Set file pointer and write file is basically going to be appending. And then we delete our keys and close our contexts down. So I'm going to hit Alt left to get back. And this I'm just going to label. Auto label. I'm going to call this crypto generate and write key file stuff. Again, when we come back through this, the next pass, we're going to refine this a little bit more. But now we have the general function of where we generate our at least one level of crypto keys. So if all we're looking for is a quick triage to find the crypto information, we could do that with just a little bit of work. So I'll hit auto label here and call this generate and write key file stuff wrapper. And I'll put this crypto up to begin with. Make sure I got those names about this crypto generate, write key file stuff. Alright, Alt left to get back. And that's good enough for this first pass. Now we're going to be reading a file. We see we have a handle, opening handle, and then the R for read. And we see A is unique. So we're opening up our crypto context again. And we create a file. Now if we see the fifth argument, 1, 2, 3, 4, 5, is a 3, I'm just going to hit E to equate. And this is going to be open existing. Again, you can look those up in MSDN. I'm just familiar with the constants, so I can go straight to it. So we open existing file. If it's not there, we probably exit out. We get the file size, we read the file in, and then we import a key. And so this really looks like we're just reading in a crypto file. So Alt left to get back, hit auto label, and call this crypto read key file. I put read in key file. Alright, so now we have a write file, so we're going to drop a file. We see this has two cross references. So I get my username, get module name, check my OS version, and then it looks like I have this building a string for this run.sct. Check my OS version again, pick OS document settings or users. I see here start menu startup, so that's generally for persistence type stuff, the startup folder. Create a file, so I can see 1, 2, 3, 4, 5 is EDI. Let's see what we're creating. I'm just going to scroll up until I see EDI is selected. So we see here push 2, pop EDI. 2 is basically create always. So I can see right click, set equate, and we can see create always. I'm not going to label it here because it's not next to the create file. So we'll be basically creating a brand new file. Alright, hold on, my Ghidra just froze up. Let's see if we can save this. Alright, so this froze up on me. This happens every so often. It hasn't happened too often. Let's see if I can close it out, and I think it's going to have to basically crash it. And alright, so let's go ahead and just close this down. So I'm going to go ahead and kill this because it just locked up on me. So I'm going to do my Java, and I'm going to delete to terminate that, and then we'll open up a Ghidra again. Alright, so I'm going to open up this initial marked up. This is the one that we're just continuing, and we'll see how much of a backup is saved for me. So it wants to recover unsaved changes. I'll hit yes. and we'll see what it is. So I'm going to hit my graph view, G to go to the entry, and the satellite view, I'll just scroll down. So we see some of our stuff is saved. I have the load imports. Let's see how far it got. All right, so it looks like we got this delete file or copy, so let's go ahead and relabel this stuff. And this file was alpha label. Call this crypto generate and write key file stuff. Let me go ahead and just copy that name. And then we'll auto label the top and just put the wrapper on there. Alt left. And this read, let's double check this. All right, this was reading our crypto file. So alt left. Auto label. I'll call this crypto read in key file. Because if you remember, we imported the key file. Let me go ahead and save that in case we lose our work again. And now we have this write file. So let's see what we're writing out. Oh, this was the one with the run set. Okay. So we went through, set our settings, start menu, so we're suspecting something with persistence. We create a new file. And then we see what looks like an ASCII string here. So let's go ahead and click that, go back to the flat view. And I'm going to double click it. And then right click, and I'm going to do data and C string. I see it's a start, and I see a Unicode string here, so right click, data, Unicode. All right. And alt left to get back. So we see something with start. So potentially we're in persistence. We have a start because of location. Looks like maybe we're storing something in the temp directory. Maybe in the start public directory. So probably based on some choices, we're going to depend where we're going to start a file for it looks like persistence. Building some more strings. This is all these string cats, string length stuff is. We write out the file. And that's it. So we're basically just writing out a file. We create the file, we write the file. So we know the file has something to do with starting a file because we have start and then different locations. And then we also saw, where was it? Up here, the startup folder. So I'm going to hit alt left. So this, I'm going to hit auto label and call this drop persistence file, and I'll put a question mark because that I'm a little bit more unsure about. I don't put the stuff on there because it doesn't have anything that I didn't recognize, but yeah, I'm taking a little bit more of an educated guess based on those strings, so I want to verify that one in the debugger definitely. Now we have a function with no calls. So let's check this one out. And I see a decryption loop, simple XOR decryption, another decryption loop, and a third decryption loop. So all we're doing here is decrypting data section. So alt left. So I'm going to hit auto label, call this crypto decrypt data section. And that's probably our configuration item. So again, if we want to look for the configuration file, we could run the debugger straight up to here, check the decryptions, and see if we're right. Because we're getting that table of contents overview, it helps us easily find this stuff. Can't guarantee it's the configuration data. That's why I didn't put the configuration. It's just decrypting data. It could be other things it's decrypting. And now we're going to reading a file. All right, so I see I'm decrypting a string here, or looks like a decrypting string XOR. Another decryption. Build a string encat, string cat. I see this unique ID do not remove. I remember that string from when it was generated in the crypto keys. Create file. 1, 2, 3, 4, 5. 4, we right click. Fit the argument, set equate. And I think this one is open. This one's not as common. Open always. We get our file size. We have an I2A. We read the file in. This looks like it's going to be closed handles. We expand it out just to check. And it is. We're just checking because the APIs are the important part. We see we're comparing some byte to 3 echo. I can right click, convert. It looks like a greater than sign. right click convert. So we're doing some parsing. So we're writing a file. We're doing a little bit of parsing. Right click, convert. And then we do an I2A conversion. And then we exit out. So because of that string, where was it? I think it was unique ID do not remove. I think it has something to do with the keys, but I'm not going to be concerned about that right now. So Alt left to get back. So this, I'm just going to hit auto label and call this read and parse file. I'll put stuff. I want to look at that closer. All right, so now we did kind of our initial setup. So we delete file or copy and start file stuff. They begin the program, we probably copied and start file stuff. We generated keys. We writing a key file, probably one just generated. We dropped a persistence file, potentially. Decrypted some data section, probably the configuration data. And then we read some type of file and parsed it. Now we have get logical drives. So with get logical drives, you see this push pop right after it. The 1A you want to recognize is 26. So we go through convert. And basically we're going to be looping through the logical drives. It's just a bit mask of all our drives, typically A through Z, so 26. So this loop here is looping through it. We see a 41, which is hex alpha, or hex A, plus ESI, which we can see basically starts at 26, so we're probably going to be decrementing. And this is where we're going to be looping through all the drive letters. And we can see we're comparing AX to 5 alpha. I can right click, convert, and this is Z, so A through Z. And then we see this get drive, let's expand it out, get drive type, and we'll compare that to a 5. So right click, set equate, and this is going to be drive CD-ROM. So double click it. Again, you can look up the options in MSDN to know what to search for. I'm just more familiar with what these options are because I see them enough times. So we're looping through all of our logical drives. If we're CD-ROM, we loop back around and start over. We see the loop goes back over here. If it's not CD-ROM, then we come over here. Again, this is ransomware. The only thing this would be, I can auto label and call this crypto encrypt drive stuff, and then we'll step into it to make sure it looks consistent. But just find the location, that's pretty certain. I see a star.star and a find first file. That tells me I'm searching the directories, basically probably whatever drive letter we pass through, finding every file, building some strings. I see the string card looking for 2 echo. If I right click and go to convert, I see this is a dot. I see this 2 echo here. Go to this global variable, go back to my flat view and double click it. And I see it's a Unicode ... So I'm going to right click this, do data, Unicode, and then Alt left. So I'm searching through the directory, skipping over the dot and dot symbolic limp. And now I see a Windows string. I see this looks like a string that's probably not recognized. So let's check this one. I'm going to go back to flat view again. Let's go ahead and right click data. Actually, see if this looks like Unicode string. So right click data and Unicode. And this AHN lab. Chrome, Mozilla, Windows, so Alt left, get back. So I have what's either applications or folders, and recycle banks. So I think they're probably folders. And so my guess is these are either folders we're targeting or folders we're avoiding. We have a string, so we're basically doing some comparisons. So again, that makes me think that we're avoiding or targeting. So you can see if EAX here. If it's not null, we're going to jump over here. That means it found it. So that looks like we'll kind of exit out. If it is null, which means we didn't find it, we come through here. So that makes me think it's an avoid list. And then we can either loop through. And I'm just trying to get the general capabilities. We'll go through this more detail in a future video. Again, checking string, so just checking probably either folder options and another option, another path. Just trying to find the next API basically. And now I see this file where I write out a file. In fact, let me go Alt left for a second, go back. So I see I write out a file here. So I'm searching through my directory listing. looks like avoiding some list. In fact, here's another good indication. And then I get to this, I write a file and I crypto encrypt drive stuff. So now that tells me, because this is highlighted, you see up the very top here, the function wording is crypto encrypt drive stuff. That means I know this is recursive. So I'll hit L to label. I'm going to update this crypto and drive encrypt drive recursive stuff, because I'm calling myself again. The other thing you may not recognize is this. We'll talk about it now. Is this compare to a test with a hex 10? So when you're looping through files, a hex 10, we'll go ahead and right click this, and we'll go into this more detail. I think in a future video I'll decide, and we're going to do set equate, and then we're just going to search here for. It's actually going to be file attribute directory. So basically, when the bit mask is checking if it's a directory, if we're null, that means the bit mask is not a directory. We come down here and we actually hold on. Let me see if I read that right. We're testing if the bit mask is a directory. So if it's null, it would be a file. If it's not null, then we take this red path and then we drop some file and then call a recursive. So basically directory, and we recursively call that directory. So the only thing we normally drop inside the encryption function is usually a ransom note, because a lot of times you'll put a ransom note in every folder. So I'm going to double click this. I see decrypt information HTML, pretty indicative of a ransom note. So I'm not even going to worry about what the create file is, because I can see I do create file, write file down here, and then we just exit out. So it looks like we're dropping a ransom note. Because the location is right for ransom note, we have a decrypt information.html. I'm pretty confident that it's a ransom note, and I don't even really need to double check that. So L to label, and call this, we'll call, drop ransom note. And then we encrypt the drive recursively, call it again. If we are a file, we'll take this green path. And here we're going to build the string again for the decrypt ransom note. We're going to check to see if for this unique ID do not remove. And then we're going to build some more strings. Do something to uppercase. Now we're comparing our strings. Again, probably maybe extensions at this point. And then we have a file where we open a handle, read, and write. So again, think of the location. We're in something we're expecting to encrypt file locations. We already did the part of the directory, so now we're in the part with files. We're reading and writing a file. So this one, I'm going to hit L to label and call this crypto encrypt file. Because just by location and context, I can tell that's pretty much what it is. So let's double check it. Again, double click it just to make sure. I get some file attributes. I create file, 1, 2, 3, 4, 5. I know my third reference. I'll go to right click set equate. This is going to be open existing, so I'm opening file. Get the file size, probably read it in next. Alright, and I generate a key, do some math, set file pointer, read in the file, and then I encrypt. So again, from context, this is a big ugly function. And because we're doing the table of contents overview, we're not going to go any more detail. But this is enough verification that we are indeed encrypting the files, because the location is right, the APIs are right, the context is right, so everything basically points to it being encrypt files. So, and then if we scroll here, that's pretty much the end of this function. We find next file, and let's see what this call is. Find close. So I'm going to Alt left to get back. Alt left. Alright, so we can see crypto encrypt drive recursive stuff. So that one I'm going to go ahead and take the stuff off, because that one, pretty sure, based on what we saw, I'm pretty happy with that. I'll still want to go through a deep dive analysis to review it. So I want to see what types of files it's identifying, what it's skipping over. But from a naming convention, I have enough confidence because everything points to that being correct, and everything's been consistent so far. So we encrypt the drive recursive. In fact, instead of drive, let me hit L to label. Let me put crypt directory. Because really, even though we're likely passing a drive lever, because we have the A through the Z, it's probably just at the root we did the start at star, so it's really encrypting a directory with a find first file. Next, we had this get IPnet table. So this is just getting IP address stuff. That's not a common API, so I'm going to skip over that for now. We had this I2A string copy. We see string cat. We see a 2 echo with dot here. String cat I2A. Not really sure what this stuff is doing, but it didn't look like it's any major capability. So we're not going to worry about it at this table of contents overview. And now I have this function here, so let me double click it. And I see immediately wnet open enum and a enum resources. So if you're not familiar with those APIs, those are going to be iteratively, or actually they're going to be a review. It's like find first file for connected drives. So you're going to be reviewing the connected drives, basically getting handles to them so you can open them up. So I see a string car. So I'm going to be comparing something. I see a string cat with what looks like a semicolon. And then I see their function was already labeled. We can see up top here, it's the 402278. So it's recursive. And then we exit out. So you notice there was no unknown function here. So we are reviewing connected drives, but we didn't call any unknown function they're doing the encryption. So that means I know I'm basically getting a list of my connected drives. And it looks like that list is probably going to be separated by a delimiter with a semicolon. That'd be my initial guess. So let's go ahead and hit L to label. We call this get list of connected drives recursive. And then Alt left to get out of here. So I get my connected drives. The next thing I would expect would be to encrypt those connected drives. So again, I'm just following the code blocks. I'm not really checking the logic. I'm just following the code paths to see what makes sense logically. That's why I always review this in the order the actor wrote it, and why I like the graph view, because it's super easy to review what the general program flow is. So now I have a drop ransom note and crypto encrypt directory recursive. So again, that makes sense from context. That tells me that both these names are probably good because they worked in another setting. It tells me my get list of connected drives is probably accurate because I've already encrypted local drives. Now I'd be encrypting remote drives, so everything's adding up. Now we start freeing up, destroying our keys, letting go of our contexts, and we have a couple functions, and then we end. So we're almost done here. So here we're going to write out a file. So we have that file handle write and create a process. So let's see what this looks like. So we get our Windows directory, check our OS version, and then pick the right folder. I see a batch file, and then create file. So 1, 2, 3, 4, 5. I'm just going to hit E for equate. This is going to be create always. So open up a brand new file, get a string length, decrypt the string here. This is why I like to highlight my target instructions, so I don't have to read all those instructions so closely. String length, I write out a file, get Windows directory, and then shell execute. So this first part looks like I decrypted a string, wrote out a file, and then executed it. If I look back up at the top here, we saw we had a file which was a batch file. So we're basically building and executing a batch file. Again, I really don't like the way Ghidra shows these if-else statements. You can see this one goes way down to the bottom and basically exits out. Or we have this alternative path here, which you can see comes up to the top here. So we basically have this if-else here. So we have one option to drop and execute a batch file. The second option, I see these ASCII characters. So let's right-click, convert, and R, right-click, convert, U, right-click, convert, N. So probably going to be run as, right-click, convert, A, and one last time, S. So yep, run as, and then we execute. So it looks like we're dropping a batch file, and we're either doing run or run as based on what options. We'd have to see in details. Again, options don't matter. We're dropping and executing a file. And one potential is as an admin. So let's Alt left, get back here. So I'm going to hit L for label, and I'll put drop and execute file. In fact, I already put the stuff on there. I don't know where I want more details. And then we have one more file where we're dropping a file and creating a process. So let's go into here. Get our Windows directory, again, picking our directory structure based on the OS version. Building strings. We see desktop. We drop a ransom note. We create a file, and this too, I'm going to hit edequate. This is going to be the create always. We get a string length, we write out a file, and we see this decrypt information HTML again, and then we execute. So this one's a little bit confusing because we had this drop ransom note, and then we also have what looks like we're dropping probably a ransom note. So we had the decrypted information, and then we're executing it. So that's actually, well, I think we'll look at that in, again, a future video. I think that's actually just a little bit of poor programming, but for now, we're not going to worry about it. It looks like we're putting a file on the desktop, and we're executing it. So we're basically dropping the ransom note on desktop and opening up. So Alt left. So because this was a little bit unknown with the drop ransom note and then the string from the decrypted information, or the decrypt HTML, I'm going to L for label. I'm going to drop and open ransom note stuff. I'm going to leave the stuff on this one because I want to verify it a little bit better, just because the logic was a little bit unclear. You can see if I would have went in here, if they didn't have this drop ransom note, and I also was building a string with the desktop, create a file, decrypt information, HTML, and execute it, I would just label that and not leave the stuff on because I'd be pretty confident. But now that one extra drop ransom note function inside of there makes me a little bit unsure about it. So now let me just show you one more thing. So if we look back at our steps, so we didn't create a mutex. We did have a thing where we decrypted data configuration, so we'll have to check if it's a configuration or not. It didn't look like we tried to elevate to admin, so we just ran it as is, so not the most efficient. And we went through all the functions, so we would have seen it. We did check the region against the avoid list. It didn't terminate targeted process of free file locks. This is a little bit of an older ransomware, so maybe they just didn't do that back then. We encrypted the local drives and remote drives. We dropped the ransom notes. We didn't perform networking. And we didn't see delete shadow volumes using VSS. But if we go back here, in fact, you see here, this is generally done near the end. And we go back here, near the end, we have dropping execute file stuff. And remember that was as one potential as an admin. If you're deleting the backup copies with that VSS or BCD edit, a lot of times it would be an admin. So most likely, I can hit auto label here. I can probably, actually, we're not going to label it now. When we look at that in the debugger, when the next passes through, we're probably going to see that that's likely going to be deleting the VSS, using VSS to delete the backup copies. That way you can't recover your files that get encrypted. So from here, just from context, from knowing the general structure of ransomware, I can be probably 50-50 guess that's the kind of deleting the backup copies, the shadow copies. But for this stage, we'll just leave it here as is because it's good enough. And then as we're going through and rechecking these names and improving them, then the context will help us rename it better. So let's kind of scroll through this one more quick time since we have everything labeled and just show you how easy it is to see. So we spent probably a little bit more than a half hour with that, maybe 30 to 40 minutes. I went obviously a little bit slower because we were doing this for kind of training and to kind of spell this stuff out, even though I did do it relatively fast. But we got this free space, whatever this initial code is that doesn't really look part of the malware or part of the ransomware capabilities. We load our imports. We check for the target language. We delete a file or copy stuff. We'll have to see what that is. Generate a keys. Probably read in the key file we just generated. Maybe we create persistence through this persistence file. Decrypt our configuration data most likely. Read and parse file stuff. Not sure what that one is. And then we go through to get logical drives. We encrypt our drives. We do something here with IP addresses, and we'll figure that out next pass through. And then we get lists of connected drives, and we encrypt the connected drives. And then finally, we end up by dropping, executing a file, which is probably going to be the deleting and backup copies, dropping, opening a ransom note on the desktop, drop a persistent file. Again, a little bit unsure about that. That's why the question mark. Why would it get called twice? And then finally, delete file or copy and start file stuff. So probably since it's the end, this is going to be delete file. Maybe it's self-deletion. We'll have to kind of review that a little bit closer. So with that, 30 to 40 minutes, we got a good table of contents overview. If we want to look for IOCs, we can basically know all the functions and roughly what they perform, so we can go straight to them. We don't have to randomly look at cross-references and not have any context around us. So you can see with just a little bit upfront work, this deep dive process can help you do either triage or do a full in-depth analysis. We're going to write a report. So that's really all we needed to talk about this video. Again, the hashes are in the video description. You can download from Malware. When I'm done with this video series, we'll have at least a couple more videos to finish this deep dive process. I will put up the marked up Ghidra database in my GitHub page, and those are going to be linked in the video description. I would definitely love to know what you think about this type of deep dive file or deep dive video series. If you'd like the format, trying to figure out the best format, because I don't want to spend too much time and go over every single function. So trying to find a good mix of showing you the deep dive process and for training and not having everything labeled out for you. But that's really all we're going to talk about this video. In the next video, we're going to continue this process and refine the names and start looking for more of the IOCs, trying to figure out maybe a little more detail how their crypto works and things of this nature. So I hope you enjoyed the video today. If you did, please like the video and subscribe to my channel so you get notified when new videos come out. I also love to know what you think, so leave me comments below. If you want more reverse engineering tips, follow me on Twitter. And if you're interested in structured training, check out my website for the malware analysis class I offer. Until next time, keep on practicing and try to learn something new every day.